Alrighty, no, number 3. An electron travels at a constant velocity of 1.3 times 10 to the 5 meters per second. How much time is required for a displacement of 1 meter? This is the velocity, it's in meters per second. This is the displacement, it's in meters, which means I shouldn't have to do any conversions at all because I'm dealing with units. Oh, what's going on here? As I was saying, so I got V bar. Is he going to let me draw in here now?
No.
Apparently it's going to let me work now. V bar equals d over t. How much time is required for a displacement of 1 meter? So I put my velocity of 1.3 times 10 to the 5 in there. My displacement is 1, and I solve for t, right? And so my t is going to be 1 over 1.3 times 10 to the 5. And you should get an answer of 7.69 times 10 to the minus 6. Now, minus 6, that would be scientific notation. Like, I would not want to see 0.0000769. That's too many zeros. I got to actually count them to see if you got it right. Okay? If it's more than 2 or 3 zeros, I can't just look at it and see. I need to see it in scientific notation.
But when you figure it out, doesn't it give you 7.69 to the power of negative 6?
Yeah.
So that's right, the power of negative 6.
That's what that is, times 10 to the power of minus 6, yeah.
Same thing?
Same thing.
Oh.
All right. A spaceship traveled at uniform velocity of 3.2 times 10 to the 4 kilometers per hour for 2.7 days. 2.7 days, so what do I have to do? Gage, what do I have to do?
Yeah, you gotta put days into hours.
Got to turn days into hours, exactly. So it's going to be 2.7 times 24 hours in a day, and I hope I don't have to tell you how many hours in a day.
12?
It comes to 64.8 hours.
64.8? Okay, and then we're going to go V bar is equal to d over t. The speed is 3.2 times 10 to the 4. The displacement is what we're solving for, and the time is 64.8.
What's the number? What are you multiplying by 24 there?
All of the numbers are here.
2.7,
Right?
24.
All the numbers are right there.
Oh,
Right?
okay.
Ooh, and I get a pretty big number. I got to put it inside of notation. 2.07 times 10 to the 6. 2.07 times 10 to the 6. And that would be in kilometers, wouldn't it? Right? Because this is kilometers per hour.
I put minus, I left minus the big number.
I wouldn't. If it's more than 2 or 3 digits, I can't tell, and I have to count, and I don't want that. No, if it's in scientific notation here, you should give it to me there in the answer.
I can't even. So it's 2.0.
2.07 times 10 to the 6.
Positive 6.
Positive 6. This time I got a motorbike traveling at 85 kilometers an hour as shown. How many seconds will it take to cover a 200-meter track? I got kilometers an hour and I got meters. What should I convert?
Meters per second.
Go to meters per second. Okay. So 85 divided by 3.6. Okay, you could do it to kilometers if you want. But it does say how many seconds, and so I should probably be working in meters per second, because it says how many seconds will it take. So this is going to be 85 divided by 3.6. 2.36.
To get to meters?
Yeah.
Isn't that 85 kilometers an hour?
85 kilometers an hour divided by 3.6. I get 2.36 times 10 to the 1, which is really just 23.6. I happen to be in scientific notation on my calculator.
If you're going just 85 kilometers to meters,
Then it's not 3.6. No, it's 85,000, right? Yeah. It's because it's kilometers per hour. So 23.6 is my speed. So now I'm going to go V bar is equal to d over t. I take 23.6, 200, solve for time. I get 8.47. 8.47 seconds.
Really?
Yeah?
I got 2 points. I did mine.
So let's move on here. We got, so that was constant velocity. All of those situations were assuming that the velocity was constant over the entire time. What if the velocity changes and there is an average velocity? Now, so once again, the formula way is going to be pretty much the same, right? It's just v bar equals d over t, okay? But what if there's more than one displacement? Okay, so in the 5 that we did already, we were assuming a constant velocity for a certain period of time. Now we're talking about different velocities over different times, and we want to know the average. So for example, a bike travels 3.2 kilometers in 45 minutes. What's the average velocity? That's an easy one. That's like the ones we just did, right? That's a single one. That's just going to be v bar equals d over t. Now my 45 minutes should be converted to
Hours.
we could either go hours or we could convert our 3.2 kilometers to meters, right? The 45 minutes, I'd like to do it that way. So what that is going to show is a displacement of 3.2. And I'm going to put 0.75 down there. Now, most of us know that 45 minutes is 3/4 of an hour, which is 0.75. But what if it's not 45 minutes? What if it's 47 minutes? How would you convert 47 minutes into hours? 47 divided by 60. Very good. 47 divided by 60. Okay? So this gives me an answer of, if I do use 0.75, I don't even have it here. 4.26. And that's going to be kilometers per hour, right? Kilometers per hour.
So how come it went up?
How come what went up?
How can we change that from 45?
Because it's in minutes and I need to convert it to hours. Because my 3.2 kilometers, it's in kilometers. Like I guess you could go kilometers per minute, but that's not really a unit of speed that we use, right? We would use kilometers per hour, and so my minutes have to be converted to hours.
Why did we change
We could have 45 minutes.
from 45 to 47? Why did
No, I just said because people can do 45 minutes if they know that's 0.75, right? But what if it was 47 minutes? Right? It isn't, but what if it is? Okay. All right. The second one here, a vehicle travels 30 kilometers east in 15 minutes, 45 kilometers west in 20 minutes, and then 10 kilometers east in 7.5 minutes. What is its average velocity? This time, the vehicle goes east, and then west, and then back east.
How are we supposed to do that?
I'm going to show you.
Yeah.
How many people think you could maybe take the 30 kilometers divided by the time, then do the 45 kilometers divided by the 20 minutes, then do the 10 kilometers divided by 7.5 minutes, take those 3 velocities and add them together and divide by 3. Would that give me an average? It would be, but it would be wrong. Okay, it wouldn't work. Why wouldn't it work? If I gave you a quiz that was worth 2 marks, and then I gave you an exam that was worth 150, and just took the average of the two, would that be fair?
No,
Why not?
because you may get 100% on one. And
You might make slip up on the true and false, right? Even if you didn't know, you might slip up, get 50%. Even if you get 100 on the exam, you'd have a 75. Does that seem fair?
Yeah.
Because the exam is worth a whole lot more, right? The 20 minutes is worth more than the 15, and the 20 minutes is worth more than the 7.5. So you have to weight it. So the only way to really, really do this is to find the total displacement. And the total displacement is 30 kilometers east. Displacement, not distance. 30 kilometers east, and then 45 to the west, which is going to be minus 45. And then another 10 kilometers east. Right? 30 minus 45 is minus 15 plus 10?
-5.
Minus 5. My overall displacement is minus 5. What's my total time? 15 plus 20 plus 7.5. 42.5 is right. And now I have to take that 42.5 and divide by 60, right?
Why?
Because it's in minutes and I got to convert it to hours.
Are you gonna have to?
Yep. 0.71 hours. Right? 0.71 hours. Now I've got my displacement. Now I've got my time. V bar is d over t. Displacement of minus 5, time minus 0.71, sorry, 0.71. And I get an average velocity of minus 7.06, something like that, kilometers per hour. That's how you do it properly. You have to find the total displacement, you have to find the total time, and then divide them. Does that make sense? Nod and say, yeah, I'm good.
Yeah.
Because if I don't see nods, then I don't know I can go on. Well, like to the next one. Logan gives me 2 thumbs up. Brad has a question. All right. Example number 3. This time, you'll notice that I'm going east and then north. So can I just use positive and negative?
No.
Can't, right? East and then north. So in other words, the situation looks like this. I go 1.2 kilometers east, and then I go 0.8 kilometers north. And then this value here is my displacement.
You do your final minus your initial.
0.8. Oh, sorry, this is 1.2. Doesn't really matter. 1.2, 0.8, right? You guys go ahead and finish that one while I do attendance. You can do it. You have the skills to do it.
It's on 23.
Okay, let's have a look here. So you should have done d squared is equal to 1.2 squared plus 0.8 squared, giving you an overall displacement of
1.45.
1.45?
Yeah. Well, 5 if you round it off.
Okay. Now let's take our time. Our total time is 25 minutes plus 15. Would you guys be okay if I wrote 25 plus 15 all over 60? Would that be okay? 25 plus 15 is 40 divided by 60.
Is
0.67?
Yep.
Well, I got 6.67.
Okay. And now I'm going to go V bar equals D over T, and I get 1.45 divided by that.
2.16. 2.16.
2.18?
6. How'd I get 2.16?
Depends on how you round that 0.67, where you do it. 2.18, and that's going to be kilometers per hour. Right? Connor, watch. 2.18 kilometers per hour. Now, Logan, do you think I'm done? Ready to go on?
No, you have to put a direction on it.
Why do I have to put a direction on it?
Because it's vector.
Exactly.
Damn.
You have to put a direction on it.
North, east.
You need an angle.
What?
You need an angle, not just this. So it's going to be opposite 0.8, adjacent 1.2. 0.8 divided by 1.2.
What's that first one? I got the same as
It's the
you.
same value I've got up here, 0.8, right?
Oh, yeah.
What's wrong?
Why, is it not the same as that one?
It's either 2.17 or 2.16. It's
Like,
like,
yep. That's going to be east 34 north. East 34 north, right? East and then north. 3 different ways to find, or 3 different possible situations where you're finding the average velocity. The major rule is, the big idea is that you have to find the displacement and divide by total displacement and divide by the total time. You can't take individual ones and then average them at the end. Did I do any averaging there?
No.
Okay? Can't do that. And even though I say that, there'll be still 3 or 4 people that try it on the test. Don't do that. Don't be those people. Okay. Another way we can talk about average velocity is by determining the slope of the line joining 2 points. Okay? So, for example here, in interval A, right, if I want to know the average velocity for interval A, well, it's going to be the slope of this. It goes up 6, right? It goes over 2, so my slope is 3 meters per second. My average velocity is 3 meters per second. Now, is that a constant 3 meters per second? Is it a constant 3 meters per second? Yes, it is. How can I tell? It's a straight line. Can you now do, I better help you out here with F. If I'm trying to find the average velocity for F.
Find 2 points.
You gotta make that line.
What kind of line?
That's
The curve, the
The tangent line?
Yeah.
No. Tangent line is reserved for instantaneous velocities. What you want to is connect the endpoints, right? You want to find the slope of the average. So you connect the endpoints there. Okay, go ahead and do B, C, D, E, and F.
You really connect.
B should have been 0, right? The slope is 0.
0, 6.8.
C is
-4.
-4. You go down 16, right?
Yeah.
Go down 16. You can even count them if you want, right?
Whoa.
Down 16 and over 4. -4. D is 0. E is up
6.
Up 6 and over 1, is it?
6.
So that's 6. That's right.
And
then the last one, the curved one here, you start from there, you draw a line to there, you find the slope of that line. So
0.8.
that's up 4 and over
No.
1, 2, 3, 4, 5, right?
0.8.
Up 4 and over 5.
0.8.
4 divided by 5, 0.8. 4/5. I would prefer it as a decimal. Yeah. All right. Okay. So, running out of time, aren't we?
Yeah.
Okay. Let me just finish this up, and then we'll pick up here tomorrow. Okay. So, when determining the average velocity, the following points should be kept in mind. Don't start packing up. Give me 30 more seconds. Okay. Positive slope rises to the right and yields positive velocity. Negative slope drops to the right and is negative velocity, which means you're moving which way?
Left.
Left or backwards. Positive velocity results from moving in the positive direction to the right. Negative velocity, who's packing up out there? I can hear packing up. I know what packing up sounds like.
Like this.
Can't we pack up and listen?
Positive velocity results in movement in a positive direction. Negative velocity is movement in the negative direction. A straight line portion on the graph indicates constant velocity. This means that the average and constant velocities are the same. If average velocity over more than one straight line portion of a graph is desired, you must construct a straight line from a graph from a point on the graph at the beginning to the end. In other words, if I needed you to find out the average velocity for, say, A, B, and C, how would you do that? Could you just take this slope, and this slope, which is 0, and this slope, and add them together and divide by 3? No. What do? You find the total displacement. It's supposed to be a straight line. Total displacement divided by the total time. Boy, that would be a great test question to see if people were listening.
Okay.
Why would you only go to B or find the average?
I'm just saying, if I asked you to find the average velocity, you're packing up again. If you need the average velocity for A, B, and C, you draw the line from there to there. Know when to draw the line. And the last thing, a horizontal line indicates 0 slope, 0 velocity. Object is stopped. Now, please proceed packing up.
Okay.
He didn't get the now, like, no one to draw the line. She has no idea.
Become the